Okay, this is unit number 5, video number 7. We're going to do gram to atom and atom to gram conversion, or molecules, particles, probably a better word. So we're going to look at going all the way. One of the things you want to understand, the mole is our middleman unit. So here's our mole. We can convert that to particles. We can also convert that to mass. Okay? So we have a relationship. The mole is representing groups of particles. Okay? Moles have a direct relationship to mass because we know the mass of the elements on the periodic table. If they're stable, we have lots of stable isotopes, we know the average atomic mass. So the connection between moles and mass is the periodic table. If I'm going from mass to moles, I'm going to divide by the value on the periodic table. If I'm going from moles to mass, I'm going to multiply by the value on the periodic table. On the other side, moving from moles to particles. Again, particles could be atoms, molecules, ions. It could be electrons. There's lots of different things they could be. But anytime we're going from moles to particles, we use Avogadro's number. Now, the way we represent Avogadro's number is N sub A. That's universal throughout chemistry and physics. So if I'm going from the mole to the particles, using Avogadro's number, I'm going to multiply. If I'm going from the particles to the moles, I'm going to divide. So this gives us a way to track as we're moving across. You just need some way to know how am I going to get from one side to the other. Okay, so let's do a couple problems. Let's say we have 328 grams of water. We want to know how many molecules that is. How many molecules are in 328 grams of water? Well, first thing we're going to do is go to our middleman unit. That's the mole. Since I'm starting with mass, I'm going to use the periodic table, add up water, 2 H's and 1 O. It's going to give me 18.02 grams per mole. Since I'm going from mass to moles, I'm going to divide by the periodic table, the molar mass. And that represented in our dimensional analysis right here. 1 mole is 18.02 grams. At this point, my grams are gone. They cancel. Grams of water. So I'm going to have moles where I can tell I'm here. Now I'm going to the number of particles. The number of particles I'm going to multiply. That tells me it's going to be on top. So 6.022 times 23. In this case, water is a molecule. So I'm going to have molecules per mole. Okay, that's Avogadro's number relationship. That's always per 1 mole. And that's number of particles per 1 mole. So I'm going to have 1.10 times 10 to the 25 molecules of water. Okay, if I had 328 grams of water. All right, let's do another one. Let's say we have a certain number of moles, or a certain number of molecules. 6.41 times 10 to the 21 molecules of carbon dioxide. So that's CO2. That's the number of molecules. Now I'm going to go through and say, okay, now I'm starting with my particles. I'm going to the moles. To do that, I'm going to divide. Divide by what? By Avogadro's number. So I know there's 6.022 times 10 to the 23 molecules per mole of carbon dioxide. Okay? That's going to give me moles of carbon dioxide, but I don't want moles, I want mass. I want grams. What's the mass of 6.41 times 10 to the 21 molecules? So I'm going to look on the periodic table. When I add up 1 carbon and 2 oxygens, I'm going to get 44.01 grams, and that's per mole. Now I go through, divide by Avogadro's number. Again, remember, when you have times 10, do not use the times 10, use the EE button on your calculator. 6.022 EE23. Skip the times 10 and no carry. Then, when I go through here, I'm going to have 0.468 grams of CO2.